discuss with other people, because that is the main idea of modeling. So, first of all, what is a model? So, casually say the model is a description of something. And if you have to say it more precisely, it's an abstraction of parts of reality. Why? Do we have any idea why I have to do every time an abstraction? Warum muss ich eine Abstraktion machen? If I will call it in Germany. Why I can model something without an abstraction? Why is it not feasible? Or do you know, for example, that's why I tell you now, please don't skip to slide 5. What are you knowing, for example, a model? What an example for a model? What can be a model? Was könnte ein Beispiel für ein Modell sein? Yes, there are graphical representations, and it's more formal, but make it more easier. What can be a model? For example, what kind of do you have used? For example, do you think you have used the model today or not? What do you think? Have you used the model today? In your daily business, are you using models? Or is it only something special in the IT business? And you're right, UML diagrams, entity relationship modeling, or erweiterte or extended entity relationship modeling are definitely some stuff which we have to focus on. Yes, exactly, map. For example, if you have used Google Maps today, a map is the easiest, or for a lot of people, the easiest to understand kind of a model. And why I need an abstraction, why I need to make an abstract. Why is it not working without an abstract? Because then I have the reality. For example, if I make an abstract, for example, if I want to sign to draw, for example, a 3, I cannot do it. It's because I cannot put everything in it. I make normally a model of it, or if I make a map, I cannot put everything in it. It's not working. As you can see, oftentimes when you have a model, what you have are objects. Objects of the real world can be described with symbols, so I'm using symbols. So a simplification, an abstract on it. And symbols can often be used by machines. So that is really, really important. Also, our mind is using symbols for something. For example, if I say, oh, here, do you want some bread? The term bread is a symbol for something, which I have in reality. You don't know. Is this bread with white or brown? Is this full corn, or is this with sour teig, or is it with corn, or is this with wheat? No, I have to show it normally to you, depending on what. And where we are using, for example, also models in our head, or so is, for example, if you want, for example, to predict something. If we make a prediction, we also model it, because we cannot have everything in our mind. So every time when we're talking about a model, it describes something, but it's an abstraction of the reality. And the easiest stuff is oftentimes a map. because with that I can create a structured image of reality, because I cannot put everything in. If I want, for example, to draw a map which is showing the way from Oldenburg to Bremen, it's not working. I cannot put everything on it. So I have to draw something to simplify it a little bit. So the map, it's an image of the real Earth, but with symbols, simplifications, which we are knowing. Nobody, for example, will not say, okay, a river is not drawn in blue colors or in green colors. I have a forest or fields or something like that. In red, I have normal state borders, or I have in red highways. That is really important. And I can really simplify where I'm belonging, where I'm going, where I'm at the moment, and so on. Reconnecting. This is the slides. 1 second. Sorry, that happens when I come near to my LAN cable, because my Wi-Fi is at the moment a little bit a problem. So I'm trying now. I will give somebody else the moderator. I will take it back so I can share again the slides, because it's not working anymore. So now it should work again. And oh, sorry. That was the wrong button. That and sorry for that problem. 1 second. He's now stopping my presentation. Oh, now it's working again. Currently, I have to use with my laptop my local area network cable instead of using my Wi-Fi, because my Wi-Fi is not working correctly at home. It has some disconnections. I don't know why. It started since last week. So, and now I was moving a little bit the desktop, and the LAN cable was going out, and so sorry for that problem. So a map. So when we're talking about that, we have a common understanding of it by learning it, by learning the symbols, and so it's really easy for us. So we are knowing red is normally a border or a highway, or a yellow and local, also a street, but normally it's not like a highway. It's like a Bundesstraße, so a state lane or something like that should be called. Okay. So that kind of understanding we have. Here you can see, and that is an abstraction of Oldenburg, because we are not able to draw to show you here the reality completely. It's not feasible. But now we know, okay, all that other, for example, here, really easy. There are rivers, or here are fields. Here is a street, or in this case, a highway. Here, state, or here you see some state streets, and so on. So different kind of streets, and so on and so on. All that we can see about in here. So with that, so we can have a model. So we need a models, and models are abstractions. That's what we have to learn here. So that is the main idea. Now we have to talk about there are different levels of model. And overall, we have 3 levels: semantic, logic, and physical, which we should have in mind. So we need all that, and why we are needing all that, because only with that we can find out what we need in how our database systems have to look like. So in the beginning, we are making an information requirement analysis, and then we can start with the modeling. And also the first step of the consumption to model it will be. Now we have to put anything in it, like you have said before, like Rami here talked to us with UML diagrams or models or entity relationship or erweiterte entity relationship models, so extended entity relationship models. So that is what we have to do. So how it can look like, for example, that's how it can look like. So what we are looking at is the result of a conception model that we get is conceptual scheme, or a logical scheme, or a physical scheme. So the result of modeling is called of the modeling procedures every time called a scheme. So our idea is to create a conceptual, or we will call it semantic scheme. That is the idea what we want to create. Here you see some representations, some models which we can use. So definitely we will not talk about everything, because definitely we will talk about the entity relationship model, and definitely about the extension towards the multi-dimensional entity relationship model, which was done by Forbes. We will definitely give you a short view into the DFM, dimensional effect modeling. If you're following these 3 authors, we will show you another approach and the different kind of approach, like ADAPT, so application design for analytical processing technology. And we will start with entity relationship modeling, then going to the multi-dimensional. Later on, we will show you ADAPT, then DFM, and then we will talk shortly about something that is not written on it here. So that is not a full set. There are further one, because we will talk also about data vault to something else. And that is, for example, something also what I think Michael Matern will also talk about in his practical presentation. He will also talk about data vaults and how you can use them. And if you are going further later on in logical modeling, then we should have in mind like star scheme, snowflake scheme, so the differences between it. So also we have to know definitely what is the star schema and what is the extended star schema in the end, then which was introduced by SAP. Talking about galaxy scheme, we can also talk about dimensional modeling, but I think it's not so interesting. When we talked about data warehouse, data marts, we talked about the different type of approaches, so the approach of Inman versus the approach of Kimball. And later on, what is also a little bit important, because going later on to in-memory computing, is we talk shortly about physical scheme and why, for example, some keys, how they are more normally called surrogate keys, are so important. In German, they would be called künstliche Schlüssel. Why systems are using them, and why they are important, and why they are so important, for example, for the part of indexing. And definitely there, if we are talking about physical schema, there we can talk about everything else, but we will make that really short, because The BI1 lecture is more like an introductory lecture into the topics, and then you can go really further and deep into some topics depending on your interests. So that's what we are talking about, or will show you a little bit, and then you have to learn it by yourself. But we will talk about entity relationship modeling. If I make, for example, who is familiar with entity relationship modeling? I will make a short question. So 1 second. So who is familiar with it? Who knows how to model it? Why I'm asking that, because, for example, 5, 6 years ago, I asked the same question some people, and everybody that was in presence, and everybody told me, yeah, I'm familiar with it, I can do that. Then we make a short, like 5 points question on the expert in Excel, and like 80% were not familiar and could not answer it. And I asked it before. That's why I want to know it, because what we have to do, because definitely you should learn it, how to create an entity relationship model. You should definitely learn it. Okay, 9 of 14 have answered. I give you no more 20 more seconds, and then I will show the answers. So that is really important. If you have not done it, you should learn it. And we will give you also, like here in the slideshow, you will see some small ideas about it, and you can model everything what you want. And I will show it to you. So that is the current answer. So was it not shown? It should be shown. So 6 have answered with yes, 2 with no, and 1 has not decided it yet, but that's okay. It's fine for us. So definitely we have to figure that out, and we will show it to you, what you have to learn there. Okay. Like as a small view into what will come into the logic part is, these are common schemas for the models. And normally you will focus on a star schema if you use that, because you have in the middle your fact table with the dimension keys, which is often times a compound key. You have your measurements or facts in it, which should have additivity or something like that. And around it, each fact table can be connected to dimension tables. Dimension tables are not allowed to be connected with any further dimension tables, so there is no connection allowed between these, and so on. And you are only allowed to have it like in this way, so the depth of 1, you are not allowed to have here or further, because then you would have a Starflex schema. Here you see the differences. And with that, something like that, you can build up hierarchies and all that stuff, but we are not using that. Due to that, we are limited here to that. SAP has seen that the star schema alone is not solving any or everything what should be supported, and that's why they have extended it. And we will see to that. Also, what is often be used is a snowflake schema. You see here now the depth or height is every time the same, so it's every time 2 here. So I have 2-dimensional tables here, I have 2 there, 2 there, 2. If I have, for example, here not a second one, then it would be a Starfleet schema automatically. And in the Galaxy schema, by the dimension tables, I can connect also here fact tables, so I have more than one fact table in it. And you see also here, like something like that is then allowed. So these are 4 different type of models in the logical part. So if I want to do the abstraction or how the process is normally performed, how I use it, oftentimes I have first to identify the objects. So if I make the information requirement analysis, then afterwards I have to picking and identifying objects which are interested and assign attributes to it, towards it, and to assign relations to see what is connected. It must be a manageable amount of objective. That means the manageable means that I have to make an abstraction, because otherwise it's not working. I cannot manage all objects because then I'm back in the reality. I'm showing how it looks like. So we have to decline it to make it smaller. So it must also be a manageable amount of objects, and the same for attributes and relations, because I cannot show all the relations. It's not working. That is what I'm normally doing. And I'm often classify them. So I want to have objects with similar characteristics that I want to put them into a class. And so to assign them, then I want to give them same name, which is clear, which is not 2 times in a class and something like that. All that stuff. And afterwards, hopefully, I have a semantic scheme. So that is a short path what we want to do. But now we will do it in our further procedure, how we will do that. How it can later look like, for example, if we are thinking about later on like SQL or something like that. Yes, places. What could it be? It could be something like that. We put Buenos Aires, Montreal, Vienna, Zurich, and so on all together. We're finding out what are these older cities or places, and so we say, okay, we can create classification or something like that, and we can call it places, or they belong to the object type branch. Could be something like that, or they can to the product, and you see, okay, here I have different things. So I have here to clarify stuff so that I have it later in. So if I want to have a conceptual, what is it? What does it mean? Or what does it mean conceptual level or semantic level? It means I want to describe the semantics of the application, define what concept I use, what terms I use, what relations I have there, and so on. In the end, I want to have a coordinated, harmonized terms across the complete system. So, for example, I'm not using in the end, I'm using, for example, as employees, I use employees, but I'm not using employees and workers as, for example, terms. Because it's the same. For example, if in one system I have used workers and the other system I have used employees, then I have to harmonize it. That is one of the steps we will see shortly. So this ambiguation is exactly that what we are doing. We want to have the information requirement analysis. We want to document relevant facts They should be independent from database systems. So there should no information from it, in it. Nothing from the database system, because if I'm changing the database system to a new version, then my data is changed, and it could be that I'm not understanding it anymore. The same is for any kind of application. Nothing should stand in there. And one of the commons, for example, representation, how I can represent it, is an entity relationship model. And if I'm using it, then I can use different like notations. And one of the most common used is Chan. And that's how it can look like. So that is a real easy conceptual scheme of somebody who is selling something and who's making an advertising campaign. So you see here, I have a branch, I'm selling something in some places, in some regions. It's sold on dates, so I have the information, I have the products, so I have different products, which are in different categories. These are promoted by a marketing campaign. It can be like via TV, via a newsletter, or something like that. It's promoted for a term, for a period, and that's how it can look like. That is something easy you can find and define. But you have to do that each time. And normally it's not so easy. And you have often to do that for any kind of process. Because normally, if you're in a company and you have to find out, and if you want to optimize the process, oftentimes the process is not specified. Or not everybody in the process have the overview over everything. Only some people have it. And so you have to write it down, write everything down, what is important, and so that in the end, if you model it, then you can discuss with the people, do I have everything in it, what is important, or is there something special in it? For example, if the temperature is also important for the result of the product, it should be definitely taken. It should be considered as important data and something else. And so, for example, I can have to define what kind of particular database system or what kind of information structure I want to support and how it can look like. So if I, for example, looking for a logical scheme, I can say, okay, it can be a relational system, and the easiest stuff, how to show it is, for example, here, like with tables. I have a branch here, tables with branch numbers, places, regions, and so on. Here I'm with selling, and here are my sales, and then I can make the connections. Or because we are showing you all the time the differences between semantic, logical, physical. In physical, it can look like that. It is the same showing. Here you see it this way. Here you see it how it would look like in SQL DDL. What is this telling you? I have a range number. It's not allowed that it's empty. Here you see I have a place, which is a char, which is maximum in 50, which is not allowed to be empty. A region, which is also a char with a length of 20, which is also not allowed to be 0. Then I create a table space row data. So I'm creating a table here in the SQL. I say, for example, how the storage is managed. Initially, I say it's 100 megabyte. If it's extended, it's extended with a further 100 megabyte. And The maximum extension is unlimited. So I don't say at 2 terabyte or 6 terabyte, I say now you're not allowed to extend you anymore. Now, no, we are saying here, every time it can be extended. What we are seeing is here the percentage of increase when it's increased. So it's completely increased about the 100 megabyte here, like the percentage free. That is, for example, how much space should be free. For example, for further updates, for further reloads, and something like that for changes, 20%, and so on. All that I can define. So hopefully you see the difference between what I can do on a semantics versus on a physical scheme, the differences. So that should be only the overview. So coming from the semantic scheme or conceptual scheme towards the logical scheme towards the physical scheme. And I can have in the conceptual scheme two different approaches. I can have the relational analytical processing, or I can the multi-dimensional analytical processing. We will focus here on the relational scheme with the star schema, but also something else can be focused. And you see two different companies which are mainly focusing on two stuff, like SAP with its NetWeaver, which is a relational analytical processing solution, versus the MOLAP, the multi-dimensional, where Oracle Express is one further product. So a lot of your words, a lot of stuff. And now we're coming to really the 4 steps which we have to do. Hopefully, it's will be understandable for you. Are there any questions currently? Habt ihr bis dahin Fragen? Ich weiß, es war etwas, wir wollten euch erstmal so einen groben Überblick geben, so we want to give you a more rough overview about it. As an introduction, and now we're coming to the semantic part. Okay, so we have 4 steps to construct a semantic scheme or conceptual scheme that we will discuss today or do it, and depending how many